The keynote speech that we have today, I'm really quite looking forward to. Pierre Dillenbourg has been doing some really wonderful work over the last few decades. You can read, of course, in the program his affiliation, his work, very distinguished contributions, publications, and so on. The ideas that he's been working on over the years have developed and shaped in some very interesting ways. What we'll be hearing about today, in terms of the thinking about orchestration in classrooms, I think is very important, very exciting. And as somebody who's got 2 degrees in music and actually conducted orchestras, I have some views about the metaphor as well as the execution of such things. Was talking to Pierre, realizing that I first met him back in '92. I think it was Stella Voiceniadu had organized a NATO Advanced Study Institute in Crete. And that was my first visit to Europe and my first visit to Greece. And I don't know if Stella's here this morning, but it was really a very spectacular event. It really helped me get in contact with international researchers beyond what I'd been exposed to in my admittedly kind of US-centric PhD experience at the University of Illinois and Champaign. Many of the people I met at the conference I've kept up with professionally and personally over the last 2 decades. Well, at this point, I think I really just want to give the maximum time to Pierre to share his thoughts for us today. So let's put our hands together and welcome Pierre.
Thank you, Michael. Thank you to all of you who managed to do it, who promised last night they will be there, and I think most of them are there. I don't see the Vanderbilt team. Where are you? Okay, you are there. Yeah. So, congratulations, not the girls, not only you. Okay. So today I'm not going to talk about orchestration, because as soon as you use the word orchestration, it's such a powerful metaphor that everybody fights about the word itself, about everything that it carries with it. And instead of talking about the concept, we only talk about the word. So let me talk about schmunz. We talk about schmunz, and at the end of the talk you will decide whether it's worth calling that orchestration or whether we should call that implementation or teacher's role or classroom management or whatever. But the title gives you already a flavor of what I mean. Think about a teacher in the classroom. You have 30 kids. I was a primary school teacher, 31 kids. And you ask them to log in the system, okay? 3 minutes, 4 minutes, 5 minutes. Some of them have forgotten the password. Some of them have uppercase problem and so on. 5 minutes. 10% of your lesson time is lost for login. Okay, maybe there is some good reason to log in. Okay. But do you get 10% increase of the learning outcomes if the students log in? That's an example of a very practical thing. I'm not a theoretical guy. I'm to be talking today about the practical life of a PU teacher in his classroom. So, but before to go on, a few other things that we do in my lab, more lab research. The rest will be very classroom oriented, but more lab research. This is eye tracking. We try to study collaboration by synchronizing 2 eye trackers. And here you will see 2 pairs. On the left hand side, you have a bad pair. The collaboration was very bad. We use the coding scheme for Meyer, Sparda und Rummel, and this pair on the left was bad on any criteria in terms of quality of collaboration, and the pair on the right was the best one. And now you will see the gaze patterns of these 2 pairs. So they are doing some Java programming together, and one is Mr. Blue, one is Mr. Red, and you see this bad pair. They're never looking at the same thing at the same time. They talk to each other. I don't know if you can hear it. But they never look at the same thing at the same time. Now look at the second pair.
What is this sign for?
In this very good pair, the eyes are dancing together. They are together. They are, cognitively, they are together. And this can be perceived without doing any language analysis just by monitoring. What you see on the diagonal there is the frequency of shared gaze at the same thing at the same time.
So we take the first, second, and third number, and we...
So this was the case for 2 pairs, but when we take 20 pairs, we have these findings. There is no significant difference between the very good and the medium pairs, but the low pairs are not together. Okay. The funny thing is that we can predict here the quality of collaboration in a semantic-less way. Think about all the many hours of coding that we have done in your life, and you could use eye tracker to predict that. Another nice eye tracking study just finished is it's about paper annotation. So Yuri developed this $99 eye tracker there with a camera of a PlayStation, and he has this system that we can do both eye tracking but also recognize annotation on paper, even if you move the paper. And that's my favorite result. The question was, what is the gravity of an annotation? At how many centimeters from annotation will your eye be attracted by the gravity of the annotation? And the answer is 5. Okay. I've always been jealous of the people in cognitive load. They can say it's 7, and now I can say it's 5. So this is the normal reading saccade, short saccade, and this big saccade on the top occur when the gaze is about 5 centimeters away from the annotation. So here, the quality of collaboration and this kind of thing can be predicted without semantics, which is quite cool. I do also less serious thing. Oh, by the way, this is my office. I want to show this because I have an open postdoc position in the lab, so I think you might want to see a few pictures of Lausanne, you know, and the life at EPFL, the Swiss Federal Institute of Technology. Like we ski in the morning, we sail in the afternoon, and in the evening we have great wine. So some work on robotics. On the left-hand side is this modular robotics, that object can change shape. And on the right-hand side, the little box there with the kit is called Ranger. In French, ranger, which is to put the toys back, you know, to tidy your room. So it's a robot that moves and smiles when the kid brings the object back to the... So also some ethnographic research. Okay, now let me talk to my... So you understand I'm a gadget man, from these few examples. I'm a gadget man, but I would like to call them serious gadgets, like serious games. And I will show you gadgets that work well. And what do I mean by work well? I mean that we did 5 years of design-based research with these teachers, that it's now used in 20 classes. We have pre-test, post-test score. I will show them. But when it really works well, it means that when the experiment is finished, when the funding is over, when the researcher is not anymore in the classroom, they continue to use the system. And that's not often the case. So what I want to do today is to say, okay, in some way these things work well, but I don't know why. That's the problem of design-based research. Despite everything you claim about a conjecture map, sometimes it works well, but do we have a theory that could explain why some particular design reduce the Schmunz load? The orchestration load is the cognitive load on the teacher. Where is Paul? Paul is there. Paul, cognitive load is dead for learners, but no, I save you. Cognitive load is back for teachers. Okay. Now, orchestration load is more than cognitive load. It's also the physicality. It's not only cognitive. So let me show you one of these gadget stories. It started like that in Switzerland with a vocational education, like in Germany, Austria, which is dual. 1 day per week at school, 4 days in the company. That's the basics of the Swiss economy. 2/3 of the teenagers are trained like that. Any plumber went 3 years or 4 years to school in this system. And we work with logistic assistants, who are people who drive forklift in a warehouse. And we went to interview these guys, their boss, and so on, to see what they learn. And the result was a bit sad. They don't learn very much in the warehouse. They move boxes as fast as the boss asks them to move. And logistics reasoning, they're supposed to learn logistics. For instance, the product I sell every day should be close to the place where the trucks arrive. And the one I sell seldom should be on the back. These logistics things is not for them. It's for the boss. So at school, they have a course of logistics, but it doesn't make sense because they never reason in a logistic way in the company. So there is a gap there between the school and the company. And it's a good gap. It's a good gap because the school has to be more ambitious than the needs of the company. But we still had to address this gap, and to do that we developed this simple augmented reality system where the kids have plastic shelves that they manipulate, they put on the table, and above the table there is a lamp that includes a camera and a beamer that can overlay information on the tool, and this is, or it looks like. So as I said, it's now sold to 20 classes. We use paper as an interface. I will talk a lot about that today. Why is paper damn so good? Then the system gives feedback. There the forklift cannot pass, cannot drop a box. On the left you see that it beams on the sheet of paper direct information. And then you can run the simulation. You see on the left the performance of the warehouse. How many seconds in average to bring a box from the shelf to the truck? That's one of the learning activities, but we have many others. This is called picking. This is about how to load the truck correctly. And finally, this one is about stock management. Like, see, that's quite difficult. If you ordered strawberries when there is no strawberries, your stock is empty for 3 days. So how do you manage that? Okay, nice gadget, funny, it works well. When we do experiments, we compared this tangible thing with a multi-touch table running exactly the same software. They learn more with the tangible. Okay, and I like this result because we are so much over by the multi-touch advertising that everything is multi-touch and multi-touch is happiness. I like to see this result that these 1 cent shelves are actually more effective than a multi-touch. Why? Basically because they go faster. Okay, they can move things much faster than when they are like that with the, trying to move things with their fingers. You have a tactile feedback, you have an audio feedback, it goes faster, so they explore more solutions. And because they explore more solutions, they learn more. But also, they tell us a lot of story. So I remember one of the guys say, oh, no, not like that. Because in my company, the boss has his office there. So we never pass in front of the boss office. We always turn around. So they connect this. And it's funny because it doesn't look like a shelf physically. It's an icon. But still, they connect to it. And you never moved a shelf with 2 fingers in real life. But still, they connect it a lot. So it works quite well. But if you leave them, this guy, 15 minutes alone, what are they talking about? These are tough guys, huh? They move boxes. What are they talking about? 2 most important things in life. Soccer and girls. I'm not talking about women's soccer, no. 2 topics, soccer and girls. So now, basically they play and they say, well, my warehouse is fast. And then the teacher say, why? You say, well, I don't know. It's a bit too playful. And so we developed some tools that allow the teacher to push them into reflection. Like here, they copy, you see the beamer beams on the sheet of paper, they copy that, they go to the whiteboard, we have 4 of this lamp per class, so the teacher can compare and say, well, why is your warehouse faster than your warehouse? How? You have broader alleys, so the forklift can go faster. Obvious, but then you have less storage space than he has, and he can push this guy into reflection. So that's the idea that it's not only playing, it's also reflecting. But honestly, the results were disappointing. we compared. So the first one was a control lab study. When we go into the classroom and we compare this nice software with the paper, the same task on paper, there was no significant difference. Okay? Because there are so many other things. Well, I must say that the teacher in charge of the control condition, the paper, said, I am going to be better than the technology. You know, this guy from uni. I am going to explain so well that my students will be better at post-test than the other one. There is no way to beat teachers who decide that. So, but when you analyze more closely the quality of dialogues, you see that in the bad pairs, the ratio between when they talk about the concrete manipulation versus reflection about why is a warehouse better than another one, this ratio is very bad. And in the good teams, they reflect more. So playful technology in some way, it's what Zondolen called manipulation temptation. A playful technology in some way inhibits reflection. What can you do as a teacher to manage that? So Son came with these paper keys. The teacher has paper keys in his pockets, and this one is called simulate. So the kids build a simulation, but they build the warehouse, but they cannot run the simulation. They have to call the teacher. Then the teacher comes and he says, well, do you think it will be faster? Yeah, yes, sir, yes. Oh, why? Explain why. Is it bad? Justify, rational, and so on. So the teachers do not let them play with the simulation. And when they are ready, then the teacher shows the card and the simulation runs. And if it's a very good team, you can leave the card to the team and manage. So this card is playing with a certain number of cards like that, allows him to manage the classroom in real time. Something you might call orchestration. So you will see some interesting picture. No, that is my favorite card. Pause the class. You know, imagine you are a teacher and you try to explain something to this 16 guy completely in a playful mode. You know, the technology spoils your life as a teacher because there is no way you can get their attention. So you take this card, pause the class, stop the world, and all the screen become white. Nothing happened, you can explain, and then you show it again, and you can continue the lesson. The teachers really enjoy that, but it was not all. Some developed some kind of cockpit or dashboard where, I don't know if you can see clearly, there are 4 lines on the top because there are 4 teams in the classes. Every box is one of the solutions they saved, and we have this yellow to red visualization, which is a number of moves of the shelves. So when it's red, it means that this team is in a tinkering mode. They're really playing to. It doesn't say it's bad, but it says to the teacher, maybe go and have a look at that team. Maybe they are not reflecting as much. And you can also choose 2 of these solutions and compare them in terms of performances. So with this set of tools, there are some other tools. Yes, we manage to have significant learning outcomes. So Frank asked the other day, do we have some empirical evidence of the effectiveness of orchestration? Yes, but I must say, he put in the system like 6, I showed 2 tools, but there are 6 or 5 or 6 different tools, so we don't know exactly which one is responsible for, but for engaging these kids into not only playing, but also reflection. Here is a nice picture about the teacher. You see, he's walking in the classroom like that with the cards in his bag. And the funny thing is that I said to Son that this is too much. I said, this is way too much for a teacher. I prefer use little orchestration cards. This dashboard is way too complex. But I must say the teacher loved it. And the teachers love it, and it was significant in terms of learning outcomes. So, that's a nice gadget that works, and now is the question, why does it work? Why is paper so good? And to try to answer this question, as I said, I will go into 12 steps. And the first step is to simply define orchestration as the real-time management of an activity graph. So the lesson plan, the script, the pedagogical scenario, whatever you want to call it, is a sequence of activities distributed over 3 planes: individual, team, class. Vygotsky called that intra-psychological, inter-psychological, and social planes. And and they are distributed over time. Not a big deal. If you want to compare, for instance, a standard lecture with a Mazur-like method where he makes the lecture and then they use clickers, the students have to answer individually and then they have to convince the neighbor to change his mind, and then we compare the result in the slide of the teacher and we continue the lesson. So very simple notation. We can describe many of these lessons like that. Problem-based learning. The one in the middle is Ton de Jong's and Annie Gayler's script for simulation. You introduce a lesson and then you ask individuals to bring an hypothesis, and then you discuss the hypothesis in the classroom and you find students who have conflicting hypotheses and they have to use the simulation in pairs. Okay, so not a big deal. We have a directed graph which is spread over 2 axes, time and I'll call it pi, the different social planes. The links between these activities model a data flow, and we will be talking about that. Maybe one more example. It's an old script that I use in my own teaching. First, to trigger argumentation in teams, first we ask people to answer an individual questionnaire. There is no right or wrong answer there. It's a questionnaire that measures the opinions, and then the system makes a graph of the opinions of the student in the classroom and make pairs of people with opposite opinion, since we want to trigger conflict, social cognitive conflict. Then the guys have to answer the same questionnaire again, and that's a good argumentation phase. And then the teacher has a debriefing phase, as very often in the script I made, where he compares the argument brought by all individual and all pairs. And finally there is an individual writing phase. So it's very simple. 2 comments. One is about pedagogical integration. This is not about collaborative learning. Collaborative learning should not be a religion. We don't really care about collaborative learning. It's about individual, collaborative, lecturing, everything we try to integrate. And as Janet pointed out, it's about integration. It's not about, from a technological stuff, it's not having one system. These things at different levels can be different systems. And if you look at the work of Jim's team, at the work of Yanis, at the work of Miguel, most of the scripts run over different technologies, but they are integrated into one simple story. You might say, but Pierre, for instance, during a lecture, we still have an individual brain functioning. So what the blue line indicates, the thick line, is the focus. The current focus is at the class level. But of course, when you're at the team level, we still have a brain functioning. So what this graph indicates is what is the current focus of the activity. And to be a bit more complete, we should have these 3 more levels. The periphery, which is activities that involve the people with a permanent relationship with the classroom, the director, the colleagues, the family, and so on. The community, which is people with a temporary connection, like you go to a museum, you go to a zoo, whatever, you have a temporary relationship, and then you have the world. Okay, that's the first step of my argumentation of why, to understand why some design produce good orchestration. Second step. How to package Alzheimer pills. The problem, it's a nice design problem, because if you have Alzheimer and you forget that you have to take pills, it will not improve. Okay? So, and if you don't take the pill has no effect. Okay? If the pill is empty, the pill, if there is no molecule, it has no effect. Well, there is still the placebo. But if it's a wonderful drug and you don't take it, it will have no effect. And here, actually, the effectiveness is not only on the molecule, it's also on the packaging of the thing that will make sure that, for instance, somebody with Alzheimer and forget he has taken a pill will not take 10 times the same pill during the day, because that will be detrimental. So with this kind of relationship, we have a molecule that is embedded into something that will carry the molecule, and there are many of them, which is itself embedded into what they call a dosage form. It can be a syrup, it can be a pill, it can be a patch, and finally this is packaged. And I want to make this metaphor with educational design. The instructional design The learning science gives you in someone the core activity, the main thing that will trigger the cognitive process you want to do. But there are a lot of things around that I want to talk about today. And let me call it the kernel, the blue center, the one that has been designed, I call that the kernel. And I have no discussion that this is the most important thing, okay? Good learning theory that allows you to design nice learning activities. But when we design technologies, we should not only think about the kernel, about everything. And I will give you some examples. For instance, about the login. Let's start first with what I call emergent activities. These are activities which are very close to the design, but they build on the production of the students. Something very difficult for teachers. Teachers don't like that much improvisation. Okay? You don't become a teacher in general because you love improvisation. You choose a job that will be a routine job. Okay? And then suddenly in some of this script you say, well, the last part of the lesson you will build upon what the students have produced. Wow. That's not easy. No? That's not easy. So we have to think about technology that help teachers to do this kind of improvisation. But the classroom is populated by other things which are not part of instructional design, which are just part of the routine of a classroom. So revisit, like if you give a lesson on the square, okay, you will give a lesson on the square, pre-test process, but then you probably teach the square 2 or 3 more times with the same kids. You will come back a few times on the same content as if you are a teacher. You will give them homework to do. You will ask them, for instance, to copy. Why do kids copy? They spend a lot of time copying what is on the blackboard. Teachers have good reason, but you agree that we are quite far away from the learning design. It's part of daily life in a classroom. We have all these routines. In my case, I was a teacher in Brussels a few years ago. The dark blue is 20% of the daytime, clearly. And the rest is these other activities. Can we support them with technology? We have a good example in the logistics case, which is this homework. So the kids play with the simulation, and at some point they save the best design they've done. It's printed, and they go to the company, and we ask them to discuss that with the teacher. No, not with the teacher, with the boss of the company, okay? Well, the people in charge of them in the company. And the teachers told us, no, you are ridiculous. All students never do homework, you know. They are tough guys. They never do homework. And as you can see, 90% of them did homework. Why? Because paper is a fantastic invention. You know, I don't have the patent, unfortunately. No, they go to work like that, and then they say, hey, boss. And they show this sheet of paper and say, you know, which one is close, which one of the design I made in the company are more similar to our company. And if they had to ask the boss, can we sit a few minutes on the computer and we will log in and I will type http// and that will take 15 minutes, the boss has no time for that. But during the coffee, and that's enough. That's enough. So it's paper, make this workflow. And Ulrich always said you have a media, how do you call that, media break, discontinuity? Oh. Merci. Thank you. And yes, we have. But it works so well. And then you have a lot of things in the classroom that have nothing to do with learning, like to log in, to move the table, to distribute the sheet. And there are so technology, we can think about that in the technology. So for the login, for instance, I don't know if you notice, but there is no login, nothing there. The teacher has a binder with the curriculum of the year. He turns the binder, he takes a sheet, he puts it on the table, and the activity is running. Nothing else. He can take notes, he can make a copy for his colleague. It's like that. It's stupid, but it works so well. We never thought we will do paper. We never thought we will do tangible. The project was about location-based technologies. But by working with the teacher, we arrive naturally to this design. And then in the daily life of a classroom, there are a lot of other things happening all the time. Like there is a kid which is missing. What do you do with him? In our work, we say, well, it's experimental mortality. We remove this guy from the data. But he's coming next week for the second part of the lesson, and the teacher has to manage this kind of dropout. So the worst of this event is not the fire, because if there is fire, you can just stop the lesson. It's the crane. I don't know, for those of you who have been teaching, especially if there are boys in the classroom. You teach, and then suddenly a crane stops in front of the window. And you cannot beat a crane. You know, all the boys, only boys, will stop. No, you cannot do anything about it. The only thing you can do is to teach rotation. That's so you may at least start to do that. So, but all these events, can we anticipate them in our design? This is an example of another script where we say, okay, it was teams of 3. One was playing the role of Piaget, one the role of Vygotsky, and one the role of Frank Fischer. And and what happens if Frank Fischer is missing in the team? Vygotsky and Piaget complain. They say, well, we have to do more work than the other teams. It's unfair. So there was this spy button that you say, okay, you have no Frank Fischer in your team, but you can borrow the work made by the Frank Fischer in any other team. So this orchestration I try to put your attention on these daily things that do not deserve a theory, but that will spoil the most effective learning technology that we have. So, I call that the bloominess of an activity. You know, if an activity really results from the design here, then I have a bloominess of 1. But then, how far you go from this? Like login has no pedagogical design in it, and that is a bloominess of 0. So I invite you to think about activity that range over the whole spectrum of bloominess values that I will represent on my graph, simple with this color. Now, to describe an activity, so we have pi, we have the time, we have the bloominess, and then we have many other things I will not describe because we have IMSLD. So we don't have to go into these things. There are some standards to describe this activity. Okay, step 3. When you design this activity, the teacher has some constraint, tough constraint, or people learn, who are my student. But orchestration puts the focus on some other constraints. And there are many of them. Being a teacher, you have to manage all these constraints in real time. One is time. A teacher is always kind of managing how much time is left. The fact that time is segmented. Control, discipline. I don't know, in learning science we never talk about discipline. It's not politically correct. But a teacher, especially a novice teacher, that the main concern is, you know, do I survive? Do I manage a class? If they learn, that's not bad, but so we don't want to go into that far, but we have to think that some of the discipline, some of the iPad stuff, for instance, kill the teachers. You know, if you are there and all the kids are playing with the iPad, it's not easy to keep control of your classroom. Leaving traces. In some way of virtual stuff, sometimes they leave no physical trace that the kid can show to his father when he's going back home. And then he's home and say, the father said, what did you do today? Well, no, I have everything here. He say, can I see something? No, that everything is there. Well, that's what my daughter does. And no, that's not, I want to see some of the trace. The energy of the teacher is something we tend to invent pedagogy that works for wonderful teachers. We will spend the weekend analyzing the data while we are skiing. You know? Like the other day, I had a colleague, he said, Pierre, should I make teams of 2 or teams of 3? Well, I say, I can start to make a comment about the American view, the Japanese approach, and so on and so on. Then I said, but by the way, how many students do you have? He said 140. I said, make teams of 6. You know, otherwise you will have to grade, 70 assignments. We have to consider this is a constraint that we kind of neglect in learning science. So can we again design technologies? This is the one where at some point in our graph we had to wait for the last student, because when I made the system, I say we go to phase 2 when all the students have finished phase 1. It makes sense. No, sometimes for some reason, at some point you say, oh, well, no, I bypass any decision. We move to phase 2, even if not everybody has answered, because time is passing and I want to be in control. This one is more physical. Which of these 2 lamps is the best for orchestrating a classroom of teenagers? The black or the white? One of them is bad with teenagers. The black or the white? Who says the black? Why? Yeah. The black one is bad? Why? It's good. Oh, they can be moved, both of them. They are a bit bulky, but the black one is bad because you don't see the kids, you know. And if you don't see this guy, maybe they will smoke. You don't know what will happen, you know. A good teacher is always scanning the enemy in the eyes, you know, and from, you know, like that. And there, no. I said teenagers because with primary school, I don't know here, but in Switzerland, very often in a primary school, there is a corner with one computer where the teacher sends 2 kids to do some activities. Then this cozy one will be nice for primary school. But for teenagers, you have to keep them under permanent control. So we have this script, which is a kind of rigid workflow, and during the lesson we have to adapt it all the time. This is a simple version of adaptation. Can we make it a bit longer? Can we maybe postpone it? Can we maybe turn a classroom activity into an individual activity? That's not enough. What the kind of flexibility we need is more like this one on the right. Is, I don't know if you know this sort of creator. This for me illustrates well what a teacher has to do during the lesson. He has this graph, but he's constantly trying to change the graph. Okay. It's a simulation. You can tune the rigidity, flexibility, elasticity of these edges. So what is the flexibility, the elasticity of the edges in our graph? That's a good question. So let's have a look at these links. So, so what are the links between these activities? Basically, these links have a nature, they have a fiber. So what is the relationship between activity A and B? A can be a prerequisite to B, an advanced organizer, a la Ausubel. It can introduce a didactic contract for the rest of the lesson. It can motivate for the next activity. It can bring the logistics for the next activity, or it can get data. The output of A becomes the input of B. And when you have this data flow, you have a set of operators. If you read the paper from Collard and, Collard, and all, we describe these activities like the data from A aggregated into the data from B, or the other way around, group formation activity. The teams of B are made from the answer of A, group rotation, you would shift role, and so on and so on. We can have a very clear specification of this. Then these links have a strength. The strength is the probability that you can succeed B if you don't succeed A. Okay. And 1 minus this probability. So some of the activity, like motivation, is important, but sometimes the teachers say, well, the strength of motivation is not 1. I can succeed even if I don't do this introductory example. I can still do my stuff, so let me skip it because I have no time. So if the strength is weak, you can break the link. And then there is an elasticity, like this motivation, for instance, will decay with time. So it's not a yes or no. These things, all the an advanced organizer, if you do it 10 minutes before it works, 10 days before it doesn't work. So there is a decay of how much you can stretch this link. Once in the argumentation graph, between the argumentation and the debriefing, instead of having 1 coffee break, I had 1 week. So I stretched the link, and it was a complete failure because all the energy of the argumentation phase was lost. So that was the third step, fourth step about the flexibility. Now, flexibility and workflow are 2 words which are not going well together. A workflow is a set of wires. So a flexible workflow is a paradox. It's like a modest French, or a nice German, or let me see who I should insult more. So a flexible paradox, a flexible workflow doesn't. These 2 words do not go together unless you come with no nice HCI solution. Like this is a flexible workflow, this sheet of paper. So we are moving now into what is the usability of this technology. And I have another nice question for you. Look at these 4 computers. They have 4 different colors. Okay? Why? Are you getting crazy that the color of the computers has an influence on learning? Pierre, you smoke too much. Why are they different colors?
Because they go to the red lamp, or the people in the red lamp, or the people in the yellow lamp.
Yeah, it's simply easier for the teacher to refer to them. Okay, not a big deal. But it introduced my next concept, which is this three circle of usability. Like in usability, we talk about using one human-machine interaction, then we have usability at the team level, and now there is a new concern. The color of the lamp only becomes interesting if you consider usability at the classroom level. And to get back to my pill example, it's like the color of a pill. You would say the color of a pill has no influence on the health, except if you make, for instance, pills that look like Smarties, and the kids eat all of them, and then you have to bring them to the hospital. Yeah. So the color of the computer is like the color of the pill. So what is this three circle of usability? So the one is individual cognition, then you have team, CSCW, CSCL is the circle 2, and now there is another circle of usability, which is consider the classroom as a user, not the teams, the classroom. You would say, well, that's not, again, another metaphor, the classroom as a user. But Etienne said, oh, a cockpit remember its speeds, okay? So the cockpit and the team in the cockpit constitute a distributed system, and how can the teacher offload some of the cognition on the classroom? It's what I'm going to address now. Let's get back first to paper. Actually, in the example that you have seen, on this sheet of paper, there are 3 layers of information overlaid on the top of each other. One is printed in advance, one is beam in real time, and one is unwritten. Okay? And these 3 layers compile, and what I will talk in the next 5 minutes is about the relationship between these 3 layers. For that, I will show you another activity. When we found that paper was so good, we thought, oh, we will use paper to teach geometry. Paper is cool, you can rotate, you can fold, you can do a lot of things. So here is an example where you will find again these 3 layers of information. It's used in 3 different primary schools in Switzerland. We have many activities, but this is about angle. So the first one will be a simple activity, where the kid has to learn to use a protractor. And they have to learn to use a real one. The teacher wants us to use a real, not a virtual one on the screen. So they take this plastic protractor and they have to measure the angle. So the exercise is make an angle of 70 degrees. So the kid tries to do it, and then when he thinks he's done it, he has to check. Well, not quite, so he has to adjust a little bit to make his angle, and then that's it. Now he has to make an angle on the other direction, clockwise, and which is quite often difficult for the kids to understand that you can do an angle on both sides. So now he's doing a 55, but on the wrong side. So the systems tell him. Okay, that's a very schoolish activity, but then we have a nicer script a bit further in the video. Okay, in this second script, the table is split in 2. On one side, the kids have this sheet of paper which is about satellites. You have to shoot some old satellites that turn around the Earth. So to do that, you have to compute the angle of the shooting. So one team measures the angle and have to tell the other team where they should shoot. Okay? Because measuring an angle is mainly a communication thing. You can communicate the angle to the other ones. So you write down the angle and the station from which the shoot should occur, and he gives that over the little wall. He gives that to the kid on the other side that will choose the right station and then shoot to hit the satellite. Once he's ready, he can prepare the shoot. And he missed it. Okay, and there are a lot of discussion because quite often the mistake is that they don't say if they compute the angle clockwise and anti-clockwise, and they have to invent some convention between the 2 parts of the team to communicate which kind of angle they are talking about. In this one, we use symmetry. So here, what is printed is the axis of symmetry. The kid draw one of these, the one on the top there, and the computer project the other symmetry things. The next one is an example from carpentry. Still the mixture of paper. Here we train carpenters, also a vocational system, and we have again these different paper objects where the students have to learn 3D reasoning. So they put a block there, and the system projects a 3 orthogonal projection that they spend many years learning to draw and to compute. And they can see the construction line that connect these 3 orthogonal projections. And there again we have a variety of learning activities. I will just show you one, which is a game where one student puts a block, saves it, and then give the block to another student who has only 2 views. And with his only 2 views, he has to find out how to position the block correctly. This is not so easy to do. So there again, we have 3 layers of activities, which is we have things on the paper, things beam, and things drawn by hand. Okay. I'm not saying that paper in general has properties. You will see in these things they have different kinds of paper. We have sheets, we have cards, we have... It's not one thing paper, we have a variety of things. Okay, so the nice thing about this thing is that it creates handle. If you want, we have 2 layers of information. We have, in the solution I show, this graph is actually, we have 2 graphs. One is the physical, one is the digital shallow. And what we do with these tags on paper is that we connect these 2 things. We connect these 2 layers, and we can manipulate the digital layer by manipulating the physical layer. And these 2 layers have different values in terms of information persistency. So how long the information remains displayed. For the print end is forever. For the written is from when I write, and for the augmentation, what is beam, is temporary. It's only when you are below the lamp. And all the design has to match the persistency of the display with the validity, the length of the validity, so that the information, like in the middle line, should not be displayed when it's not valid anymore. So we have to match the validity and the persistency of information. So how do we play with persistency? So you saw an example. How much the kids play is now stored in the system and displayed in this dashboard. And I want to show you a second example, which is this little thing here of how do you play with the persistency of information. This is called a lantern. This is made by Ahmed Alavi in a completely different context, which is physics. University lecture this time. Okay, Ahmed went to observe this classroom, Physics 101, 2 hours of lecture, 2 hours of exercise. They received a sheet of paper, the guys, and they start to do the exercise, and when they need help, they call the teaching assistant. And you will see what happened when they call the teaching assistant. So the teaching assistant is the lady standing in front of the blackboard, and look at the students here. So this is the toughest course of EPFL. We select 2% of the best students of Switzerland and half of them fail. Physics 101. And look what this guy is doing. Nothing. And now she's available, he got her. And the guy on the top who was continuing to work with a hand like that did not get the teaching assistant. Okay? So why he's doing nothing? Because he must monitor the assistant so that as soon as she's available, he can grab the teaching assistant. You know how much time? 60%. 60% of the waiting time, they are like that. The toughest course of BFL. I like to have concrete problems like that. So what Hamed invented is this lantern. So the guys enter the room and they put this lantern on the desk. The color of the exercise indicates which exercise they are working on. There is a color grid here. Why? Because if everybody is on exercise 1 and I am on exercise 5, maybe I can wait a little bit. Okay? The number of LEDs indicates how much time you have been working on exercise 5. Why? Because if everybody, if I read the question and I had help, I will never become an engineer. Okay? First, I should try by myself. Okay? And then when I need help, I push on it. And it starts blinking. Very slowly, and then faster and faster. At some time, the teaching assistant comes, he presses, and it indicates how much time the teaching assistant stays, because we had some teaching assistant that stay 30 minutes, especially if the team is made of 4 blondes, then they tend to stay longer for some bizarre reason. And so this is very simple technology, very stupid, huh? There is no intelligence at all, very basic, very minimalist, and yet the wasted time was reduced from 62 to 6%. They're stupid. The guy push. That's it. They have nothing else. They walk, and at some point, they push. Okay, we have a lot of other results about that in terms of time dynamics. But so it's a buffer. This is a buffer because I'm trying to push an information vision of the classroom. This is simply a buffer of information, and this is an immediate buffer, and the teacher receives later on a summary. So how much time they spend on the exercise, how much time they've been waiting, and so on. So this leads me to a view of classroom from a Shannon viewpoint as an information theory thing. I'm not an expert in information theory, but all my friends at EPFL are. That's the problem, you know. Every time we see a tree, they compute the entropy of the tree and so on. But there is something a bit different. So in this Shannon vision, there is an emitter that sends a message. So in the Shannon vision, this guy is not emitting a message to the teacher, unless he's snoring. But in my view of orchestration, this guy is emitting a clear message. So what is the information? How can we adapt the information theory to what's happening in the classroom? Well, if we could reverse the theory, it said that any object in the classroom is an emitter, and that there is a signal if somebody perceives or look at the object. So if I don't see the students, there is no signal. If I watch them, there is a signal. So Shannon would kill me for that. So, and there is a basic beat. And I thought a lot about it, and I came to a conclusion, it's 1. It was a long reflection. 1 second is more or less matching cognitive load theory, is matching eye tracking data. In 1 second, you have the time to scan the classroom. So to consider that every second, the teacher scans the classroom and gets all this information. There are 22 kids, okay? And the teacher has, let's say, for every kid, he has about 15 pieces of information. The name, the gender, whether he's active, whether he's attentive, whether he has understood this and that and that. 50 information per kid, that's not a lot. And if there are 3,000 seconds in 1 lesson, 50 minutes, then this is the cognitive load of the teacher. How much information in a Shannon view, or well, no, not Shannon, neo-Shannon view, the teacher should accumulate this kind of information. But of course, on the other side, we have the cognitive load theory. Okay? It has to be 7 plus 2, 9, plus 1. I gave my 1 like that, Paul, if you don't mind. Now, because the teacher, when you are teaching, you are in a maximum. Let's imagine the maximum cognitive load would be 10 for him. But then we have to divide by 3 because it's not only thing he has to do. He has to think about the content that he's explaining things. So it's not only orchestration. So there is something wrong in this equation, as you notice, and you say, yes, of course, Pierre. We know that experts chunk. So when there is a complex data, experts extract chunks which enable us to say it's still 7 plus or minus 2. And I discussed that a lot with Dan Schwartz in the Yosemite. And he came with this, well, maybe we worked a bit too much. The idea is that from a cognitive load theory, encoding all this information is not possible, you know, if you think about a verbal way. But if you think about the physicality of the classroom, this complex information might actually be quite simple. It's not that the teacher is chunking, it's that the classroom in some way, is revealing patterns, and that, so this impossible cognitive load, actually, we manage it quite well as teachers because of the geometry of the classroom. Like when we have all these classes with all these lanterns, none of the tutors complain about the amount of information. So which brings me to my final step. Okay, can we go further than that and model quantitatively the classroom? So this is not very serious, okay? You should not take this too, well, you should not take anything I say very seriously, but this is pretending, okay? Let's imagine that we have a function that takes a set of competencies, a set of students, a time budget, and a context. X is the context with the constraints. And then you have a learning theory, and that produces an activity graph. This is instructional design. The orchestration is the change of this design with two goals. So I have now finally, Frank, a definition. I don't know if you will like it. It's a real-time management of the multi-plane. We've seen that. Multi-layer, we've seen that. Activity graph. That maximize constraint satisfaction, we have seen that. And minimize entropy. So there are two understandings of this entropy. One is the physics one, which is nice, because you want to avoid increase of chaos in the classroom. There is no heat produced, but noise. But that's not mine. It's more the uncertainty. The teacher has to minimize the certainty about the knowledge of the students. And so what is the activity graph? We've seen it. A graph in the graph theory is defined by a set of vertices, and we've seen these vertices in my talk by a set of edges, and we have seen this, we've defined these edges in my talk. So we have substance to move into a theory of orchestration, and the entropy is the sum for every student and for every feature of the students of the uncertainty, multiplied by the time less the persistency of the information that we have done. And this persistency depends on the information and of the layer when I explain the different layers of information. So this is not serious, okay? I will delete this slide before to give it. But I thought there would be smart people in the room, and that might take my slide and say, maybe we will do it seriously. Because we're not far from this graph, we're not far, and if you look at the classroom as an information system, not as for the learner, I'm talking from the teacher point of view, as managing this massive flow of information. For instance, we say a good teacher has an eye in his back, because while he's writing, he's still collecting data from the background like that. So, understanding orchestration as this management of a massive flow of information. I would have liked to come with a theory today. I did not. But I have an appetizer of something that could become a theory. So, a few final comments. First of all, why do we do that with hardware instead of using an iPhone application, a phone application? We have this phone for 10 years actually. The students can ask for help, and the teacher receive the list of teams waiting instead of these stupid things. Okay? Because this is much more acceptable. It's in the background, it's there, it's a bit poetic, the student change color. And if you are the TA, you receive this list, okay, no, go to team number 3, no, go to team number 5. So what we have done in the design is we deliberately reduce the quality of information. The resolution was reduced. Instead of showing the exact time, we give an indication in the background of the time. That's a technical flavor I wanted to give today. It's not smart. It's in the background. It's minimalist. We could do many more things. People tell me, Pierre, why don't you put a mic and a small keyboard? And say, that's a laptop. So it's minimalist. It's in the background. So in terms of design feature, the technology I showed you can be described as we try to help the teacher to be in control of the classroom, discipline. Visibility, these things are great because even when you are 5 meters from the table, you see what the kids are doing, not with an iPad. Flexibility, I insisted a lot on that. It's all physical. They like to touch, they like to push, and so on. This minimalism, that's a meta principle. Less is more. We always invent technology with more, 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 more. And the last point, we should design for normal teachers, you know, normally motivated, normally smart, but not for the few heroes. And when we do experiment, quite often, when you read the paper, or you learn that the teacher in the classroom is a friend, or is a student at the university at the time, or is the husband of one of your colleagues, or something like that. Now, that's not, you know, we should design for the everyday teachers. Not, and, you know, I don't know in your case, but when you talk to the teachers of your kids, sometimes it's so far away from learning science, the daily concern, and we should design for these people. So, my 12 steps toward the theory of orchestration went into 3 stages. One was really about education, and I stress this fact that orchestration do not replace a learning theory. It's not a sufficient condition for learning, but it's a necessary condition to scale up. Okay. But it's not a learning theory. A learning theory remains the most important thing. But still, some people like me can work on the packaging of your beautiful learning theories or learning activities. And then there is a lot of HCI. And I think there is not enough HCI in education. What I did is a lot finally connected to HCI. And at the end, I tried to move into information theory, a more formal account of what's going on in the classroom. So finally, I come back to the first question. Is orchestration a good name? Why I told you today, is it the same as classroom management? I don't think so, because classroom management is mostly discipline. There is more. Is it the same as implementation? I think it has a special flavor. And I put Piaget and Vygotsky because you had this fight, oh, right there. They had the fight about inner speech and egocentric speech. Okay? Basically, it's the same concept. When a kid speaks aloud without anybody around him. Piaget called it egocentric speech, Vygotsky inner speech. I don't know who used the first term, who was the first to call that inner or egocentric, but probably people would stand up in the room when Vygotsky was speaking and say, why do you call that inner speech? Piaget called that egocentric speech. And you know, as people say, why do you call that orchestration? We have other words for that. And actually, egocentric speech, for Piaget, is something kind of negative. In the development stage, the kid is not able to take the other's viewpoint into account. While for Vygotsky, something positive. It's a step in the internalization of speech. So it's worse to have 2 concepts, or 2 words for the same. We had the same discussion about Manu's concept of productive failure. Okay, it's not new, but at the same time, sometimes having a new word encompass something. In my case, this word comes from Franck. I remember one meeting where he said, it's orchestration. You remember that meeting? We were in Munich, I think. And I think it has a flavor. It carries something different. And what is this flavor? It's about the little details that kill the teacher's life. Why is Al Capone there? Because Al Capone was not sent to jail for his murder, but for his taxes. You know, these little things that will kill you. So I have this Al Capone view of the classroom, that we should design technology that maybe they're not worth a theory, but that we should try to, in the design, when we design, we should consider not only the learning theory, but also these little details that kill the teacher's life. Thank you. Thank you. Questions?
Yes, indeed. Yes, thanks so much, Pierre. I guess just time for a couple of relatively quick questions, since we still do have other sessions later on, and we do have the break. So please just open up to the floor. We do have a hopefully working mic, although we've been promised things before.
Thank you, Peter.
You're welcome. Yeah. Thank you. A great talk, as always. One of the things that I began thinking about 10 or 15 years ago was recasting our work in educational technology in terms of the ergonomics of learning environments. Excuse me. And it seems to me that actually we might have made more progress in improving classrooms by getting rid of pedagogy and bringing in ergonomics to understand the dynamics of activity and people and tools and space and so on within those environments. But of course, there's often a sense of conservatism about that you can't both improve work processes and have a very user-centered, action-based interpretation of what's going on. So the question I wanted to ask was, I wonder how it is we can train new generations of developers and researchers who have the skills to bring together both that ergonomic sensibility but also the pedagogic sensibility. So you've got some great people you work with. If we want to do replications of that work more broadly, how might we get people with the right kinds of skills and sensibilities together?
The answer is on the next slide. I mean, I don't think we have to train them. I think these students are just so good that I don't really think we should train them. And this is why it's on the last slide, because I forget to thank them. I forgot that slide where I have to thank all these people. Especially I want to thank Natasha Ongelofeluk, who has done a lot of work there. I have to say I love you, Natasha, because of all the work she has done. And so I don't, first part of the question, opposing ergonomics and learning science is like asking, should a woman be beautiful or smart? There is no reason. These things are not exclusive. Okay, so in our case, it's funny that when you talk about the ergonomy, it's like if we should stop talking about the pedagogy itself. But to answer your question concretely, I don't know. These students are, and I don't think my students are better than your students. I mean, if you give them, let's say, the freedom to do HEI in education. So my students are like that. Hey, Pierre, we are not really an education team, huh? That's a bit, old-fashioned to be education. We are an HEI team. So, but I say, okay, no, we are in education, but HEI is too easy. But HEI in education, I think maybe we should create a master in education. HEI in education, something like that, to make them understand that there is a field there. To which extent is there a need for an HEI theory specific to education? And maybe we should do a degree like that to attract them.
Okay, how about one more relatively short question?
Okay.
Everybody's looking forward to the morning tea and something hot, I'm sure. Well, listen, it was a wonderful talk, and you've certainly earned the right to have one of our something to sip on.
Thank you.
Thank you.